again, electrochemistry fans. So we've seen how we can predict what kind of reaction will occur in a cell when we throw a bunch of chemical species into a bowl and just mix them together. And we wrote half reactions and matched their electrons and combined them. When you do that, you get a balanced reaction. The coefficients in it are valid. And if you can get a balanced reaction, then you can do all the stoichiometry stuff that we've taught you before, and it works the same with electrochemistry as it does with any other stuff. So I suppose we could just tell you that and ask you to trust us, but instead let's do a little practice and reassure ourselves that yes, stoich still works here. So in a redox reaction, what mass of bromine will be produced if potassium bromide solution with acid added to it reacts with da-da-da-da-da-da. Okay, so like in the previous questions, we're going to start with just a mixture of different species, and we'll figure out what reactions are going to occur. We'll get a balanced reaction, and then we'll do stoich with it. So they're talking about potassium bromide. That's water soluble, so it'll come apart into potassium and bromide ions. And acid tells us that we have hydrogen ions, and that reacts with sodium perchlorate. So we have sodium ions, and we have perchlorate ions, and one assumes we have water because all these things are in solution. So off we go to our redox table, looking for our SOA and our SRA. And it doesn't take long. The fifth row in our redox table shows perchlorate ions and hydrogen reacting with other stuff. So the H plus and the ClO4 together are our strongest oxidizing agent. And the reaction given there is, it's at 1.39 volts, ClO4 plus 8 hydrogen plus 8 electrons. It's easy to get going on the wrong row if you're not careful here. Gives a single chloride ion and 4 water. Okay, so that's our SOA. Now we go looking for our SRA, and we have all these candidates here, which makes this a little bit tricky to read. K and Na in metal form are way down at the bottom of the page, but that's not what we have. We have ions, so these are no help to us. Magnesium, aluminum, sulfite, Se, Cr, hydrogen. Usually I have a good hunch what it's going to be when I'm scanning up this list, but at this point I kind of don't. Okay, I do because of something they say in the question, but we'll pretend we didn't notice that for now. Bromine ions, 2Br minus at 1.07 volts, seems to be our strongest reducing agents. 2Br minus arrow gives us Br2 and 2 electrons. Now, in the question they said what mass of bromine will be produced, which was kind of a giant flashing green light that you better find a bromine reaction in here, and this first one wasn't it. I honestly did forget that when I was starting to scan the list and then remembered halfway through, but anyway, a careful scan of the table will always get you through these. I want to combine these two reactions, but I can't because why? The electrons don't match. We have 8 electrons up here, only 2 down here. So if we quadruple the second reaction, we go 4 times 2, 8 bromine, 4 times this, and 4 times 2 makes 8 electrons. Now we have a happy reaction where the electrons match. We can throw away the electrons and smush what remains into one big redox reaction, and that'll be something we can work with. Perchlorate and 8 hydrogen and 8 Br minus, 8 bromide ions gives us a chloride ion and 4 H2O and 4 bromines. Okay, so this is our balanced reaction. And they say, how much bromine will we get? So they want the mass over here. Mass equals, don't know yet. If And then they start giving us numbers for sodium perchlorate. Now, the sodium is not in this reaction, but if you have a mole of NaClO4, then you have a mole of ClO4. Those are 1-to-1, so we can take these numbers and just use them for perchlorate. We can say our volume here was, they said 50 mil. I'm going to divide that by 1,000 to get 0.050 liters. And concentration 1.20 moles per liter. Okay, we want mass over here. How do we do this? Rule number 1, get moles. If you can't get moles, you are probably doomed. N equals CV gives us 0.06 moles of perchlorate ion. I want moles of bromine, and their ratio is 1-to-4. So however much perchlorate you have, multiply by 4 to get the amount of bromine. 0.06 times 4 is 0.24. 0.24 moles of bromine. We want its mass. Mass is number of moles times molar mass, so it'll be 0.24 times, is bromine 7990? I don't use it often enough to remember. Yes. A bromine atom is 79.90 for molar mass. There are 2 of them, so bromine's molar mass is 159.8. Mass equals our number of moles, 0.24 times 159.8 for the molar mass. Multiply those, and we get 38.352 grams of bromine. Now, it's not a stoic question until we worry about significant digits. How are we on those? This volume has 3 sig digs. The concentration also has 3 sig digs. I only wrote 2 sig digs here for the volume, but I should have gone 3 because of that. 50.0 mil, so that's on me. Our molar mass had 5 sig digs, so that's not an issue. It looks like 3 is our limit, so our answer can only have 3 digits. We should not say 38.352. We should cut that to 38.4 grams of bromine, and then we are good.